Okay, so we're going to begin Chapter 9 here, and I'm going to give you the notes for 9.1 in just a moment. But I wanted just to let you know a little bit about what Chapter 9 is about, and it's using quadratic relations and conic sections. We're going to be okay, though, because it tells us that the prerequisite skills you need to know to do this chapter are simply graphing quadratic functions, identifying the vertex and the axis of symmetry, which we just did in Chapter 4, and solving quadratic equations by completing the square. And we just did that also in Chapter 4. And solving systems of linear equations in two variables. You've done that as well, so I think you're going to be all right. Let's take a look at the big ideas here. Is writing equations of conic sections, and I'll tell you what those are when we get to that. Graphing equations of conic sections, and solving quadratic systems. So let's just jump right into Chapter 9 Section 9.1 here. First of all, I wanted to remind you that y equals x squared, the general graph, is a parabola. And just as a refresher from Algebra 1, in case you haven't thought about it for a while, if you have x in the denominator of a fraction, y equals 1 over x is a hyperbola, and it kind of gives you this graph with the two branches on it. So that's just a little bit of a refresher. Today we're going to apply the distance and midpoint formulas. It starts on page 614. You've worked with the distance formula before, you've worked with the midpoint formula before. That's a lot of what this section is about. So what I'd like for you to do is take just a moment. Actually, before we do that, remember the distance of anything is always going to be positive. So it's always positive when you're working with the distance formula. And the midpoint obviously is a point. So when you're asked to find the midpoint, you're going to write it as an ordered pair. Okay, so take a minute to do the warm-up and then come back and check your answers. Okay, so go ahead and take a look and see how you did on the warm-up. You're just kind of plugging and chugging the numbers here, and you're going to get 5. Here it comes out to this big number, but if you play a little bit with the perfect square list, you'll find out that 148 can be divided by 4. 4 times 37. You can take the square root of 4, which is 2. 2 times the square root of 37. And here, all you do to find average is just add together and divide by how many there were. So there was 2. So your answer should be $42. Okay, let's start right away with using the distance formula. When you're given 2 points on a coordinate plane, you can find the distance between them by using the distance formula. So I'm going to write down the distance formula right here. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Obviously I'm working with the 2 points here, so I'm going to label them. This is my first point and this is my second point. And I'm going to plug in what they gave me. So it's going to look like this. Signs can be tricky here, so be careful when you're working with negatives. So my x2 is negative 3 minus a negative 5, which would be plus 5 squared, plus y2, which is 2, minus 1 squared. I'm going to take it over here and simplify it a little bit. That's going to be the square root of 2 squared plus 1 squared, which will equal the square root of 5. And I'm just going to leave it like that. Again, distance is positive, so you don't have to put the plus or minus in front of there. All right, so that's using the distance formula. Here, something else you're going to have to kind of think about is using the coordinates, and they gave you 3 points here. See if the triangle is scalene, isosceles, or equilateral. Now remember, scalene is a triangle that has 3 different length sides. Isosceles, 2 of the sides are the same length, and equilateral, all 3 are the same length. So I went ahead and plotted the 3 points. And now what I need to do, yes, you need to do, is you need to find the distance between the 3 points. So I'm going to start with the distance between D and E. And I'm going to use the distance formula because I have the points here. So you got to check the distances. Equals the square root of, I'm going to just do x2 minus x1, which is 2 minus a negative 3 is going to be 2 plus 3 squared, plus 1 minus 3 squared. And this is the distance between D and E, so I'm using those 2 points right there, which equals 25 plus 4, and DE then equals the square root of 29. That's the distance, so I'm going to write it right here, the square root of 29. Now I'm going to do the distance between E and F, these two right here. E and F, so I'm using these 2 points, equals the square root of negative 2 minus 2 squared, negative 2 minus 2 right here, squared, plus negative 2 minus 1 squared equals, when you simplify that a bit, 16 plus 9, which equals the square root of 25, and then EF is equal to 5. So that means this is 5. Okay? The last one you would do then is the distance between D and F. So DF is equal to, and I'm going to use this point and this point right here. Alright, so it's the square root of negative 2, take away negative 3, so it's going to be negative 2 plus 3 squared, plus negative 2, take away 3, it's going to be negative 2 minus 3 squared. That simplified a bit becomes 1 squared plus 5 squared, which is 25. And that means that DF is equal to the square root of 26. So look at that. None of them are the same, which therefore tells me that this is a scalene triangle. Okay, the next thing you got to do is you're going to work with midpoint. So let me write the equation or formula for midpoint right up here. It's just adding the x's together, which kind of makes sense, and dividing by 2. And then, I shouldn't have done this little thingy here yet. This is a mistake. Adding the y's together and dividing by 2. So kind of ignore that little parenthesis in the middle there. It should be like a big ordered pair. You're going to end up with an x and a y for a midpoint. Alright, so if you look back here, yeah, I can't really find a picture for it. We'll just go ahead and use this formula. You've done it before. So I'm going to use the formula for these 2 points. I need the midpoint of them. So I add the x's together, negative 2 plus 4 divided by 2, and 3 plus negative 2 divided by 2. And therefore my midpoint would be 2 divided by 2 is 1, and 1 divided by 2 is 1/2. And that would be the midpoint. So this is kind of where, if you look at what our focus was, it says if you're given the coordinates of the endpoints of the diameter of a circle, so here you'd be given the points on a coordinate plane, and they'll tell you it's the endpoints of the diameter. You can find the length of the diameter by using the distance formula, and you can find the center by using the midpoint, and always cut the diameter in half to get the radius. So using the distance formula and the midpoint, you've already accomplished what it says here. But here's something else fun that you get to do. So it says write an equation for the perpendicular bisector. There's geometry. You thought you were done with that. Of the line segment joining A and B. So I went ahead and plotted A and B already. So you might want to take a second to do that. And what we need to do now is we need to find the perpendicular bisector. Now, the equation of that line. We know, you should know, any line perpendicular to this, you've got to take the slope of this and find the negative reciprocal of it. So that's kind of your first step. You need to find the slope of this line. So I'm going to put a number 1 here. And I'm going to write the slope of AB is equal to, now you have options. I think the easiest way may be just to count rise over run. So I went up 2 and I went negative 6. So it's 2 over negative 6, which could reduce to negative 1/3. You could look at it like this too. You went down to negative 2 over 6. Okay, now if you remember, a perpendicular line to this line, the perpendicular bisector slope would be just flipping that and taking the opposite of it, so it's going to be positive 3. Perpendicular bisector slope is going to be positive 3. The next thing we need to do to definitely find the halfway point so we can draw this line and come up with the equation is we need to find the midpoint. So that's our next step, find the midpoint between the two given points. So I'm going to go ahead and do that. This is negative 1, 6. This is 5, 4. So if you add the x's, it's negative 1 plus 5 divided by 2. And add the y's, 6 plus 4 divided by 2. The midpoint then would be 2, 5. Okay. Now what we actually have here is we can find the equation of the line because we have the slope of the new line and we have a point on that line. So we can refer back to our good friend y equals mx plus b, and we can plug in what we know. We know the slope and we know an x and a y. And in order to write the equation of the line, we need m and b. Well, we have what we need to come up with a b. We can plug in what we have. 5, that's my y coordinate, equals 3, my slope, times my x coordinate, plus b. And when I do the algebra here, I get b is equal to negative 1. And now I can just write the equation of the line of the perpendicular bisector right here. And I could go ahead and graph it even. I know the y-intercept is negative 1. And I know the slope is up 3, 1, 2, 3, over 1. And when I connect it, it really should go through the midpoint here, which it looks like it's going to. There you go. That would be the equation of the perpendicular bisector. All right, let's do it one more time. So we're going to do it a little quicker. I plotted A and B, so you can go ahead and take a second to do that. The first thing I need is the slope of AB, and I would just count. It's up 8 over 2, rise over 1, 8 over 2, which equals 4. So that means that my perpendicular slope will equal negative 1/4. Okay? Second thing I need is the midpoint of this line. You can almost see it here on the graph. But just to be specific, we'll just use our coordinates to come up with the midpoint. Remember what you do is you add the x's. Negative 3 plus negative 1 would be negative 4 divided by 2, which is negative 2. Add the y's. Negative 6 plus 2 is negative 4 divided by 2. And there's your midpoint. So remember, what we have now is we have the slope of the perpendicular bisector and we have a point of the perpendicular bisector. So I can go ahead and use y equals mx plus b to come up with the equation of that line of the perpendicular bisector. So again, you're going to plug in the slope and the x and the y so you can solve for b, the y-intercept. Negative 2 equals negative 1/4 times negative 2 plus b. And when you do the math here, you get negative 2 equals 2 over 4. Negative times negative is positive, and it becomes 2 over 4, which is positive 1/2 plus b. Then I got to subtract 1/2, so my b is going to equal negative 2.5, which is the same as negative 5/2. So I have my m and I have my b, and I can write the equation of my line. Now you could go ahead and plot that, realizing that negative 5/2 is about negative 2.5, so go down 1, 2, and about right there. And then from that point, you would go down 1 over 4, because this is your rise over your run. So down 1 over 4. 1, 2, 3, 4. And remember that it's going to go through this point. So that's also another point on the line, the midpoint. And you can go ahead and just graph that line. There you go. Okay, now that's a perpendicular bisector. Okay, so this last problem is an interesting problem, and I thought a lot about whether or not I should use it. But for some people, just to think about it